Here we have a problem on quadratic equation. Okay, let's go to the question. If alpha and beta be the roots of the quadratic equation x square positive px positive q equals to 0, then find the quadratic equation whose roots are alpha or beta and beta or alpha. Okay, here we have the two roots of the quadratic equation, alpha or beta and beta or alpha, and we have to find the quadratic equation. Usually when two roots are given, there is a formula to get a quadratic equation. Let me write the formula. That is x square and negative sum of the roots. Let me write the stuff over here. Sum of the roots times x positive product of the roots. Let me write it over here. Product of the roots equals to 0. So this is the formula we have to find the quadratic equation when two roots are given. Okay, now x square negative sum of the roots means we have to add the two roots. So that is alpha over beta. Let me write it. Positive beta over alpha times x, and product of the roots means we have to multiply that given two roots, that is alpha over beta times beta over alpha equals to 0. Here this alpha will cancel, beta will cancel, we just get 1 over here, and we have x square negative, and we can add the two fractions we have over here, but the two fractions have different denominators. So now what I can do is I can use cross multiplication method to add these two fractions. That is, I have to multiply the first numerator by the second denominator, that is alpha times alpha is alpha square, and the second numerator has to be multiplied by the first denominator, then beta times beta is the beta square. Divided by further, we have to multiply the two denominators, and I'm getting alpha times beta times x positive 1 equals to 0. Okay, now to complete this quadratic equation, I have to get the value of this expression alpha square positive beta square over alpha beta. For that, we have to use other information in the question, that alpha and beta are the roots of this quadratic equation. So using this information, we have to find the value of this expression and this expression. Then we have to come back to this equation and plug in the values. Okay, now let me do this separately. Okay, now let me consider a quadratic equation standard form, that is ax square positive bx positive c equals to 0. Usually we will have two roots for a quadratic equation. Without solving this quadratic equation, we can find sum of the roots and product of the roots. There is a formula, but if I want to use those formulas, a quadratic equation has to be in standard form, that is in this form. So we must have all the terms on one side of the equation, and on the other side we must have 0. Okay, now let me assume alpha and beta are the two roots of this quadratic equation. Then the sum of the roots, the formula is we have to take negative sign, and the coefficient of x has to be taken. It has to be divided by the coefficient of x square, that is a. And product of the roots means we have to multiply alpha and beta. So the formula is we have to divide the constant term by the coefficient of x square, that is c over a. Now let's consider the same stuff in our problem, that is alpha positive beta equals 2. So for this quadratic equation also, the alpha and beta are the two roots. Now the sum of the roots are alpha positive beta equals 2. So what we have to do is we have to take the negative sign, and the coefficient of x, in this case it's p, and the coefficient of x square is just 1, that is equal to negative p. Now let's find the product of the roots alpha times beta. For that we have to take the constant term q. It has to be divided by the coefficient of x square. In this case it's 1, which is equal to q. Okay, now I have alpha positive beta, that is negative p, and alpha beta equals to just q. Okay, here we can plug in this q for this alpha times beta over here, but still we have to get the value of this alpha square positive beta square. So how do we have to do that? So using these two values, that is the value of alpha positive beta negative p and alpha times beta, that is q, we have to get the value of this expression alpha square positive beta square. Okay, now let me do that on the next page. Okay, now let me consider the algebraic identity, that is a square positive b square, that is equal to a positive b the whole square negative 2ab. In this identity, I am going to replace this a by alpha and b by beta. Then I am getting alpha square positive beta square equals to alpha positive beta the whole square negative 2 times alpha beta. Okay, now what I can do is already we got the value of this alpha positive beta and alpha beta. Alpha positive beta is negative p and alpha beta is q. We can plug in negative p for this one and q for this one. Let me do it. Then we get alpha square positive beta square equals to negative p the whole square negative 2 times q alpha square positive beta square equals to, so when I square negative p, it will just become p square and negative 2q. Okay, now I got the stuff that is equal to alpha square positive beta square, that is p square negative 2q. We can plug in this stuff for this expression in the equation we have over here. Okay, now let me continue over here, x square negative. So for this alpha square positive beta square, we can plug in that p square and negative 2q divided by, and for this alpha beta we can plug in q times x positive 1 equals to 0. Okay, now to get this denominator q, what I have to do is I have to multiply both sides of this equation by q. Okay, let me do it. Q times x square negative p square negative 2q over q times x positive 1 equals to, let me multiply the stuff on the right side by q. That is, I have to multiply this 0 by q. Okay, now what I can do is I can distribute this q to this term, and this term. All the three terms are inside the square bracket. Then I'm getting q x square, and when I distribute this q to the second term, I am getting negative q times p square negative 2q over q times x, and when I distribute this q to the third term positive one, then I'm getting positive q equals to, on the right side, q times 0 is 0. Okay, here this q will cancel out, then I'm getting q x square negative p square negative 2q times x positive q equals to 0. This is a quadratic equation whose roots are alpha over beta and beta over alpha.